back in 2008, a person, or maybe a group, we still don't really know, using the name Satoshi Nakamoto published this 9-page paper, and it was about to change everything. This wasn't just about creating some new digital money, it was about building a whole new foundation for trust itself on the internet. So today, we're going to dive in and break down the elegant, powerful solution at the heart of that original Bitcoin white paper.
And right from the get-go, this one sentence from the paper's abstract lays out the entire mission. I mean, this is a direct challenge to the whole financial system as we know it. The goal? Simple. Create a type of money for the internet that acts just like physical cash. You can just hand it to someone, and you don't need a bank or credit card company stuck in the middle.
So you might be asking, why was a new model even necessary? Well, before Bitcoin, pretty much all digital commerce, everything you bought online, relied on what the paper calls the trust-based model. Every single payment had to pass through some kind of trusted third party, like a bank, to get processed. And the white paper really digs into the hidden costs of all this trust. Having that middleman adds fees, which makes tiny payments, like tipping someone $1 online, basically impossible. Plus, because transactions can be reversed, merchants have to ask for more and more of your personal info. And get this, a certain amount of fraud is just accepted as a cost of doing business. So this is the huge shift Satoshi proposed, moving from a model that's built on trusting institutions to one that's built on rock-solid cryptographic proof. The key idea here is moving away from reversible transactions to ones that are, for all intents and purposes, irreversible, making digital money finally work just like handing someone a physical bill. Okay, but this new model had a massive hurdle to clear, a problem that had stumped computer scientists for decades. It's called the double spending problem, and you can think of it as the ultimate villain in the story of digital cash. So first, the paper has to define what a coin even is in this new system. And it's not a file on a computer, it's defined as a continuous chain of digital signatures. Every time a coin is transferred, a new link is added to this chain of ownership, creating this verifiable public history for that specific coin. And that leads us directly to the big central problem. Okay, that chain of signatures proves who should own the coin, but what's to stop me from taking that same coin and signing it over to two different people at the exact same time? How does anyone know which transaction was the real one? Think about it. A physical quarter can only be in one place at one time. But a digital coin? It's just information. And information can be copied endlessly. That's double spending. And without a central bank looking over everyone's shoulder, preventing this was the absolute key challenge to solve. So, the first part of Satoshi's solution was honestly both incredibly simple and totally radical. To stop double spending without a central authority, you need a shared public history of every single transaction ever made. Everybody has to be able to see everything. And this quote right here, this is the logical core of the entire system. To prove a coin wasn't already spent before you got it, you have to be able to look at a universal record of all transactions. If it's not on that public ledger, it didn't happen. It's not valid. Simple as that. So how do you actually build this public history? Well, the process is pretty straightforward. All the new transactions are announced to everyone on the network. They get bundled together into what's called a block. You can imagine this first block as the foundation, the very beginning of the history. Then, the next block of transactions is cryptographically linked to it using something called a hash, which is like a unique digital fingerprint. It basically seals the new block to the previous one. This creates what we all know now as the blockchain. Each new block reinforces the one before it. If you wanted to go back and change an old block, you'd have to redo the work for all the blocks that came after it. And that very quickly becomes practically impossible to do. Okay, but wait a second. This whole public chain thing raises a huge question. If we have this decentralized network with no one in charge, who gets to decide what the next block is? How do we all agree on just one version of history? This is where the real genius of Satoshi's idea comes into play. This is the problem of consensus. If anyone could just add a block whenever they felt like it, you'd have total chaos. You need a system to make it hard to add a block. That way, you can ensure that only valid blocks get added to the one, single, true chain. And the solution is called proof of work. To add the next block, all the computers on the network, the nodes, start competing to solve a really difficult computational puzzle. It's like a resource-intensive lottery. Finding that solution is the proof that real-world work and electricity was spent, and it earns that node the right to add the next block to the chain. So you can think of it like this. It's essentially one CPU, one vote. The valid chain, the true history, is always the longest chain. Why? Because by definition, that's the one that has the most proof of work, the most computational effort invested in it. The majority of the network's power dictates the truth.
And this is where the math just gets wild. This table from the paper shows you just how secure the system becomes over time. Even if an attacker controls 10% of the entire network's power, their chance of successfully changing a transaction drops below 0.1% after just 5 more blocks are added. The math makes it exponentially harder for an attacker to ever catch up.
All right, so the system is secure, we get it. But why would anyone spend all that money on computers and electricity just to participate? This is the final and absolutely crucial piece of the puzzle, the incentives. What makes the whole engine run? Well, it all comes down to 2 main reasons. First, the node that solves the puzzle and adds the next block gets rewarded with brand new Bitcoin. This is actually how new coins are created and put into circulation. And second, they also get to collect all the small transaction fees that people included with their payments in that block. And this is where the game theory is just so elegant. The system cleverly makes it so that your own self-interest actually protects the network. A rational person will always find it more profitable to play by the rules and earn those rewards rather than try to cheat the system and, in the process, destroy the value of their own money. And really, Satoshi's own conclusion just ties it all together beautifully. By combining these digital signatures with a public ledger that's secured by proof of work, they created a system that's incredibly strong because it's so simple and unstructured. No bosses, no coordinators, nodes simply vote with their CPU power, and that's how everyone reaches an agreement. So, that's where we land. You see, the Bitcoin white paper didn't just propose a new kind of money, it really proposed a brand new way for people to agree on things without needing a trusted middleman. It's a template for decentralized consensus. And that leaves us all with a pretty fascinating question to think about. Beyond just cash, what else becomes possible?